Hey everybody, this is Larry, this is me going Q3 of the bi-weekly contest 150, separate squares 2. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one, I don't know, this one was a Q3, they rated this as easier than Q4, not even just in the order, but in point value. I don't know if I agree with that. I think the problem with this one is that it is trivia. And what I mean by that is that, a lot of it's I wouldn't say it's standard, but because I didn't remember it, but it is knowable, and some people just know it, right? And as a result, then if you know, obviously if you know it, then it's easy, and also there's no complication on top of just knowing it, right? It's like saying, it's like having a sorting problem, where all you do is sort the numbers and then just go. As a result, like if you know sorting, then it's going to be easy for you. If you don't know sorting, then it's not going to be as easy. Right? You have to derive sorting, which is doable per se, but it's still very tricky, right? And this is kind of like that, but it's just for something that may be a little bit more obscure. That's how I want to explain it. So okay, so even though this is structurally very similar to Q3, Q2. The easier version, or the version with separate square 1. The difference is that here, you do not want to count overlaps. Or you want to count overlaps only once, maybe more precise, right? And it turns out the solution, there's no way around it. There's no way to set it up, I think. I think maybe there's a way you could do it with binary search and sweep line. I'm not sure. I didn't really see any of that, and I tried to do that for a little bit, but I just couldn't. It felt very error prone, so I didn't end up writing that much code for that part. But yeah, but the idea behind this one is segment tree, and like I said, I don't. If you know it, maybe that's why they graded it so low, is because if you know it, then it's easy. Otherwise, you have to calculate this. I actually spent half an hour on this, or maybe even a little bit more. Actually, yeah, definitely more. Before going to Q4, solved Q4 and came back, and then solved it about 10 minutes after contest. But it turns out that I just had a silly typo. The reason why I like to explain this before is because I want to set you context, and also I feel like it's the part that is more interesting, right? Is at least if you watch my video, that's the part that I think is unique to my videos, right? Which is how I did it. No one else could tell you how Larry did it, right? Even the wrong answers and the silliness. But yeah, but we'll go over some of that. I just had some silly typos, and actually, yeah, it's a silly mistake. But yeah, but the segment tree, right? So let me bring up the drawing thing real quick. I don't. If I'm going to talk about segment tree, this is going to be a very long. Oops. This is going to be a very long video. Press the play button on my keyboard by accident. So I'm not going to go over segment tree that much. If you need to learn more about segment tree, please check out I don't know, a video somewhere. I don't know. Just search for it. There are a lot of videos on segment tree. So I'm just going to go over very quickly what a segment tree is. If it's too fast, like I said, just look for it somewhere else. I mean, this is not the intent of this video, right? My apologies. But yeah, the idea behind segment tree is that, okay, so you want to get some result. It doesn't usually people when you explain segment tree from the beginning, it's going to be a sum. But let's say you have a segment, right? Or an array, which I describe as a segment. And you want to get subarrays, so subarrays are segments, right? So the idea here is that, okay, let's say this is your entire array, and you're trying to query for, I don't know, whatever, for in this case here, right? There are other variations. I'm just explaining the most simple one, right? Yeah, and the idea here is that, okay, well, if you want to do it this way, let's say you want to get this query that we have here, then what we want to do is actually, for the tree, we would process it so that we have half, right? Like, oops, that doesn't look half enough. So this is half, this is half. I mean, pretend they're halves, right? So this is how we would construct it. It's not quite like this, but this is just to give you a visualization. But yeah, and then here, then now, all we would have to do is just get the result from here, right? So it's kind of like getting, yeah. Right, so the answer to the red part is just the sum of the answers to this part, and there's some stuff about how this is constructed. So it's actually not quite this visualization, but that's the idea behind the segment tree, kind of at a high level, is that you start at the root, you query from the left, you query from the right, and then you kind of merge them together in some interesting way, right? And there are a couple of variations on this as well. This is, you could say this is a range query. And if we want to update one, then it's going to be a point update. You can also, the reason why this is fast is that you could say that there are at most log n pieces. So if you do some operation over log n pieces, this is going to be log n. And on updates, let's say you have a point update and you update here, then you update all the components with at most log n versions of those, right? So each node will own log n. It's not quite this way, like I said, because of some other assumptions, and maths. But I think this is fine as a visualization of, if you really don't know about segment tree, this is kind of like a fine way to, yeah, just think about it. Yeah, and so okay. So for this one, how do we want to do it? Like I said, there is some part of this problem that is a little bit, what I said, trivia, so don't feel bad if you see people apparently really fast. I didn't solve this one during the contest, remind you. So yeah, so the idea here is that, okay, so again, we have a segment here. So we break down each segment into, you know, like I said, the left component and the right component, right? Oops. And we're just trying to figure out this recursively in a way. And there are really only a couple of scenarios, right? Which is that, okay, for this segment, is it 100% covered? Is how I think about it, right? And what does it mean by covered? Covered means that there's an interval covering the entire segment, right? And what I mean by that, right? So actually, I kind of, I think I skipped ahead a little bit on it. I'm focused on a segment tree, but let's actually rewind real quick on how to solve this problem. So the way that we have this one is that, that's my apologies, by the way. We have a lot of squares, right? And we have some overlaps maybe, right? And so the idea here is that this is a 2D problem. We want to we want to convert this to a 1D problem, right? And so let's say we convert it from Y because it's a little bit easier. Let's say we do it this way, right? And then now what does that mean if we kind of sweep line this way as a event situation, right? Then now that means that here, as this line goes up, the next event, say, is here, right? What does that mean? At this event, it means that here for let me change the color real quick. For here, for that segment, now we are inside a square. So here we want to say we cover that square, right? So we make a query to update it from here to here, right? And then now we keep going up, we keep going up. We actually also see, next line would be, how can we start? Okay. Here, right? And as a result, we also add here. But you can see that here it overlaps with this other line. So even though you cover more, you could just mark it as being covered twice for those areas, and that's fine, right? And then here, now you're going, okay, well, we're ending this cover and this cover. So then now we are back to 0, right, as the width. I mean, you have to do some maths to kind of calculate, okay, well, now, Yeah. Yeah, you have to do some maths to calculate this, but it's fine, right? Yeah. You have to do some maths to calculate the height, but yeah. Oh, that's because I sorted it. But yeah, and that's basically the idea for this one. So I kind of just make sure I collected my dots correctly before saying it. But that's basically it. And then as you sweep, you get all these line segments, and that's how you do the covered part. Okay, so this is how you kind of do it, and this is what I was saying with that. In theory, maybe we could keep track of all these segments using sorted list or some binary search tree or something like that. I'm not quite sure because there are a lot of things that could go wrong here, but that's an idea, right? So okay, so how did I do it with segment tree? With a segment tree, then now if you look at a segment, a segment, let's say this is a subsegment, and if this is all covered, meaning that maybe then now here for this segment tree node, you just return the width, which is the width of not the L, but the width of this thing, right? If it is not, then what happens? Well, if this is not, then it is just the sum of the components, right? The left and the right component, and the left and right components done recursively, right? What I mean by that is that, okay, well, then the total, the sum, the covered here is equal to the just left plus right. And then here is recursive in that the left, if it's covered, then we just return this width. If it's not, let's just say on the right, let's just say it's only half covered, maybe for whatever reason. Then now this one actually go to recursive as well, right? Because then now you have halfway, right? So basically now, and this one actually is 0 cover, so we could even say 0. And this one maybe now, maybe this one is now 100% full. So then now you get this width, and then now up in here you sum up these two components, and so forth, and recurse up. And that's basically the idea for this one. Like I said, it does require knowledge of segment tree, which I didn't go over that detail, but hopefully gives you an idea visually of how to solve it. But yeah, okay, so first we'll go over the sweep line real quick. So here we have the events, right? For all the x's, we compress them to x and x. Yeah. Yeah, so we just this is just so that we have all the unique x. So this just gives us all the x's unique but sorted, and then put in segment tree. We'll go over the segment tree portion in a little bit, but let's pretend this is magic. But if you do want to think about it while we talk about it, this is the segment tree with you think about what you want to do is range update, right? And also because you're updating a segment, which is a range update, and also a range query. Though this range is actually easy because it's the entire thing. So you don't have to worry about that much. But yeah, but it is what you might call it, a sparse segment tree, because x can go up to 10 to the 9. So yeah. We'll go over the segment tree in a bit, because usually I use segment tree as a black box, but in this one it is actually relevant, right? So okay, so these are the events. We have the x and the y. Yeah, right. So here this is the segment. The segment is the left is the x. The x plus L is to the right, and then we want to start it on the y height, and then we want to end it at y plus L height, right? Which is 5 at 1 and minus 1. Yeah, I was gonna try to get this together, but I end up not. So I did two things. One is that I have the total. So I wrote this function for getting the total. It's very similar to the other function, which we'll go over in a second, which solves for it. But total basically, yeah, we do a sweep line. The current width is just the query. Again, segment tree will give us the entire or the sum of all the segments. So that's what this does. It gives me the current width, and then the current sum is equal to current width times the height, right? And that's it. And here is where I'm going to point out my silly mistake, is that I just forgot this line. I probably would have gotten it if I got it, even though maybe I wouldn't have gotten Q4, so I don't know. But I was just stuck a little bit because I forgot this line, because I rewrote it from something else, because I thought I was trying to do segment tree another way, but I was wrong, so that's why. But yeah. Yeah, so this is the width, this is the height. One thing I would say is that even though this, keeping in mind that this, even though this is, I call it the width actually could be multiple disjoint segments, right? Because we have two squares that are not next to each other. So then you can think about that as just pushing them together and then calculate the area that way if you want to for visualization. Yeah, and then now we update the range after we got the sum from the previous thing. We update the range with the delta, meaning either it's +1 or -1 depending on the depending on we're adding or subtracting, right? And that's it. And yeah, and then we just sum it over all of them. And then the next part, now that we have the total, then we could calculate it again for half. So this is very much copy and paste, right? So for each event, again, same thing. And then it's just that when we cross over from, we're trying to find where the middle point intersects. And keeping in mind that as we sweep, right? If we sweep this function, only this function and this function, which is the same, well, yeah, okay. We'll only get higher, right? It's a cumulative sum, so you're gonna get bigger. And what I mean by that then, right? What I mean by that then is that what I mean by that then is that if you draw a line, you don't have to, like, unlike Q2, you don't have to binary search. Though I actually, I'll show you the code in a second that I did actually binary search, but you don't have to binary search anymore because you can solve for it, right? Because you have, here, you have the current width, you have y minus py, so yeah. So then you could just solve for it. And that's pretty much it. So you draw, so this just means that the halfway point is a line that's in between these two, the last interval. So we just have to solve for it. And this is the equation. So the way that I solve for it, I'm not gonna lie, even after the contest, the first way that I did it is with binary search. Okay, it's gonna be too much trouble. I just did with binary search, but you can think about it as that, okay, we know that, so we have this thing, right? So we know that this is, what we want to solve for exactly is that current sum is actually the bottom half. So then as we know that this is the case, right? Or this is what we want to solve for, and we know that this is going to give us the answer. So then now what we want to do is just solve for, okay, so area, of course, is the current width times this thing. And everything we know except for, everything we know except for there is some, I don't know, I'm going to call my for, oh, maybe that's terrible because that's my, but I was going to say mid-y, so let's just say somewhere in the middle, right? So we're, but everything is a constant, right? We know this one, we know this, we know the previous y, we know total, so then you just solve for it, right? So divided by 2 on both sides, right? And then you subtract current sum. So then now this would look something like that, right? Current width times mid-y minus py, right, is equal to this. And then now you divide it by current width. And then now, again, you just subtract, plus py. And that's how you get this formula. And that's how I get it, because that's the point in y. And that's what we return, and that's it. Yeah. And that's pretty much it, and everything else is the same. So okay, so let's go over the segment tree real quick. The segment tree is not that bad, but it took me a while to kind of half remember the ideas about it. And because I think I've done this only once before, but yeah. First of all, this is a sparse thing, so though I guess I already did this pushing in, but actually I made a mistake here, kind of. The only reason I actually rewrote this way because I thought that I would have to create a new segment tree. But the reason why this actually works, now that I look at this now, the reason why this works without me recreating a new segment tree is because so what's wrong with this is that I use calc on the segment tree, and then I use the second function on the same segment tree without redeclaring it. But the only reason why this works is that at the end of this, everything should be 0. So I got a little bit lucky, actually. I mean, it would have been easy fix because all I had to do is just, I mean, it may be a little bit slower, but I just have to do this again, right? So it's not segment tree. Whoops. Not a big deal. But just got a little bit lucky here. Anyway, so yeah, this is my sparse segment tree. It took me a while to remember how, not that long, but made silly mistakes, which took a while to debug. But yeah, but this is just, we know all the x's, so all we're gonna do is, there are other ways to do sparse segment tree. I don't think that. I think technically this isn't a sparse segment tree. Now that I said it, so maybe I'm wrong. I'm definitely wrong. This is actually a coordinate compression segment tree. And yeah, and ahead of time we have all the XS. I don't know. I thought that maybe I needed this, but it turns out that I didn't. So I think I'm fine here. So actually I could get rid of this. Oh, that's why this was giving me. No, that doesn't make sense. I don't know. But in any case, yeah. So this just gives me the list and sort it, and we just create the thing. So we have two components. One is the count, and count is actually probably a terrible name for it. It should be maybe covered. So we'll refactor as we will. Right. So covered is whether this node is 100% covered, right? Or yeah. Or maybe another way to think is that how many segments cover this node? That's actually more precise, but it allows us to enter the other thing. And then total is how many how much of this node is covered, right? Yeah, that's basically the two things that we need. And the recursion is, I'm not going to go over in too much detail because, like I said, you need to know segment trees. And if you know it, then I'm going too long. If you don't know it, it's going to be too long anyway. But yeah, but the core idea behind segment tree is, of course, still going to be divide and conquer, right? Yeah. And basically here it's saying that, okay, well, if this is the node exactly, we want to update the value. Either +1 or -1 in our case, but update the value, right? Because here, I forgot that I changed the name. But yeah, and this is just saying that, okay, well, one more segment. That's for the sake of me speaking. Let's pretend that value is positive, right? You could reverse it. You're smart. You could do it, right? So yeah, but if this node is this node, then we just 100% cover this node, right? If the left and the right is the order index for this node, is what I meant to say, right? Okay. And then now, if it's not, then we have to do that divide and conquer thing. So then we have to look at the midpoint, and then we go, okay, well, do we have to update the mid? Sorry, do we have to update the left side or the right side, right? Sometimes it's both, but yeah, yeah, if we have to update the left, we update the left like this. This is relatively straightforward segment tree stuff, if you know it. And this is if we have to update the right, right? This is because this is the midpoint. Yeah, not gonna go over the parameters that much, but you could kind of just reason it out, right? This is the left, right of this node. These are the query left, right, and we just kind of update that to be the left half, the right half. This is the I mean, it just kind of bounces by the left side and the right side respectively here, right? So that, you know, this could match. Yeah, and then okay, so that, keeping in mind that now we updated the left or the right, or maybe sometimes and the right, I suppose. Yeah, but and the reason I don't know how much to go over segment tree. The reason why this doesn't go like linearly is because there could be at most log n components as we kind of break down the left and the right, right? As we kind of let me bring that up real quick, the drawing. I don't know, because sometimes I forget about this, so I'm trying to emphasize a little bit. But yeah, but if you have a line segment, then it's going to be at most log n different parts from the binary thing, right? So that's why because of that, the base case holds that, and this is the base case kind of for this part anyway, right? Where it doesn't recurse is this case, and there'll be only there are at most log n of those, right? So so that's why this is log n, even though it looks a little bit awkward, I think, if you haven't seen it before. And then now, after remember, this is after we update the range, then now we know that well, there are two cases, right? One is that if this entire node is covered, then if this entire node is covered, then we just get the total, right? And here, this is the width of this segment, right? And keeping in mind that this is with the coordinate compression, right? So we do so the width of this segment is, well, variable because of the coordinate compression, right? And otherwise, then it's just recursion in the sense that otherwise the node is just the sum of the left node and the sum of the right node, and that's it. I added this ugly looking thing because of our bounds, because if you're on the right leaf node, then we'll go out of bounds, but pretty straightforward thing to fix. It took me a while to get though. But yeah, but that's pretty much it. Yeah, update range just kind of caused this thing with the default parameters. And yeah, I don't know why. Yeah, okay. I have 10 point. I have to standardize this because sometimes I use this node as 0 and this is 1. It mixes things up as a result. But the query is going to be 1 is basically what this is here. Because why is this 1? Because this is the top node. So if this is the top node is basically from 0 to n minus 1, which is the entire tree, right? So that's basically why this is sufficient, and that's it. Yeah, so complexity real quick. This is n log n, obviously. This function, well, this is O of n kind of number of events. This is log n, and this is log n. So everything is going to be n log n. I mean, we do it again, but, you know. Yeah, that's pretty much it. So actually, one thing I would say is that for this part, I actually honestly did binary search for this answer before and submitted, and it worked okay before doing this. But yeah, I don't know. Just as a heads up, I think it's interesting so that, you know, at a pinch, if you need it, you need it. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, let me show you the code real quick, and I'll do a smaller window. This is my segment tree if you want to see everything. Yeah. And this is my event sorting, and also yeah, this is getting the full area, and then this is getting half the area, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and you could watch me struggle during the contest and afterwards. Now, if it times out, that'll be very sad. Okay. Okay. Silly mistake. Okay, so this one you can only overlap once. Is that the only difference? I suppose so. Can I do a binary search? I have this window open because I want to think whether I could reuse it. However, Q4 broke out as well, so I'm doing pretty poorly on this part. On the two, both mistakes were bad. How do I count only once? I mean, I think the idea is going to be the same, but it's you do a sweep line instead, right? Maybe. It's just in there. I can't believe I made such a silly mistake. Two silly mistakes. How does this work? What is the easy way of doing it? Is there an easy way of doing it? I feel like there is a Leetcode problem about this. About the area. Okay, what if we don't have to do binary search? How do you do the area of? That is an area, right? I mean, or that is a Leetcode problem. I'm trying to find. I feel like we did that, not that. Is it just how do I do the? It's definitely a sweep line. How do I do it? Okay, well, even the total is actually different, right? Is it just compression? Can I just do path compression? How would path compression look? So many silly mistakes. X and Y, how do you confuse it? Okay, focus. And I knew it. Okay, no. You get mad at yourself later. Sweep line and then just keep set of interval, right? I mean, that is a Leetcode problem that we've done before. I'm trying to find it. I'm not gonna lie. because I've solved this before. I've tried to find my code from it. Because basically you just keep track of the intervals with a sorted list or something, right? Let's say we sort on the Y. It was rectangle. I'm too slow today. Yeah, I just can't find that code, honestly. Focus, focus, focus. Is that gonna be fast enough? I'm actually worried about performance. That's what we want to write, but how are we going to solve it this way? N square, and that's too slow. I have to do a sorted list, but I'm not even sure anymore. Oh no, that's the way to do it, but that's so annoying. I don't have the code. I can't find my code, pre-written code with. Like, I feel like I've done it recently, but I can't find the code, so. Leetcode. Let me see. I'm just going through the list of problems, on Leetcode problems. That's how desperate I am. Well, because I don't want to rewrite it, because it's so easy to make well. Make it well, maximum. I can't remember. It's one of the sorting ones, sorting interval things. I think this is it actually, from like a couple of months ago. But how long ago? 2 months ago. I don't know why I'm doing this. Because I now just sweep, right? Is that right? I think I'm already doing it wrong, because it's making the same mistake as the part 1, because symmetry matters. Okay. I don't know. These will always be the defense, right? Really, it should be only within a bracket, but still, okay. So then now, I don't know why my math is so bad, but okay. Okay, so it then this is not helping anyway. Something like this, but Trying to think what I can use this for segment tree. Maybe that's a little bit cleaner. What it's done is just adding that. And I have no time with this one. I don't even know what Q4 is. Alright, maybe segment tree is the way to go. Where's my code? Path compression. Okay. Oh, not path compression. Okay, fine. And I'm not good today. But okay, so let's say about that, right? Then now we want to focus, we're going to sweep on Y, so we want distinct X's, right? now how do we want to do it? Am I so bad today? Okay, so I mean this is easy, but we have to figure out the width a little bit better. What's my running time? 5 seconds for part 1. This is going to be a pain to get right. Might have to convert it to whatever. Okay, but let's focus on getting it right first. Well, this is always going to be... No, that's not true. Okay. Okay, let's just say we're trying to get all of them right. Actually not great. It's kind of big. 100,000. Maybe it's okay. So then now we want to add okay, so then now we want something like that. But how do we want to write it? Right. We have to get the height, which is the hard part. Okay, so this is the previous overlap. So update range allow us to, it's just delta minus the previous one to get the new parts, right? So that's the current width. Is it? For those width. I think that's right. For positive. And maybe even negative. Then how to do current sum. Something like this. I'm so bad today. But, that's definitely not right. Oh, I see. Because so that's -2, which is probably not a good area for the thing. Why is that? So it goes 1. This is just. Why am I getting? Okay, I mean I know why, but 001. And 1 is just wrong as well. The y's can be the same, maybe? Is that why? From 0 to 1. From 0 it creates 1, okay? From at 1. At point 1 it goes to 1. The current width is wrong. The current sum is right, but current width is wrong. Why? That doesn't make sense. Doesn't make sense. This is not delta. So we have the previous. So this is the previous with this chunk. Now we want to update it by increasing it by this. That doesn't make sense. That made no sense. What you want to do is count the number of zeros-ish. I don't know what I'm doing, right? Should have done it the other way, but okay. Am I messing up? Why am I thinking this way? Okay. Am I thinking about it wrong? Probably. This makes no sense. What am I doing? Okay, so we want to And we already compressed X. This doesn't make sense. What am I doing with seg3? Sweep line is probably the way to go. No, delta doesn't make sense. I think that's why. It should be 1. And then that will give you the number of things. But then now we have to compress it, right? The problem is that X is compressed. So this would work if it's not 1U9, actually, but man, I'm so not in shape. Wouldn't send 3 people got that one? Maybe I should have gotten that one first then. Alright, let's do another 10 minutes and then we'll see if we could do the other one. But okay, I think I know how to do it. Maybe. Okay, focus. focus. Do I need lazy propagation anymore? It is someone like this. Not quite sure about this one. Fuse right. Wait. This entire thing is true, and it's just left and right of this thing. Yeah. At least does it give me the entire thing correctly now? Hopefully, at least. What does this look like? The previous stuff looks okay. The width is just something like that. I keep this in here. Y2. A lot of typos. That's not great. That's probably just because I'm recursing too much or something. I don't know. That doesn't make sense though. What? Why? What am I doing? Wow. I didn't have a base case for my thing, is that why? Why would this be? Why would I have a standard out if I didn't calculate it? Oh, because of this. Okay. Then it's the update range. Is my base case wrong? I mean, that clearly is wrong. What am I doing wrong? That's just a silly mistake then. Okay. Okay. I don't have enough time for this. Today is a mess. Should have done Q4. 800 fielded Q4, and today is rough. I feel like I'm close, but not quite. What am I printing? Where's the print? There's a print, extra print. Oh, that's right. My current width is always 0 for some reason, so we update range. Something is missing here. Okay, so otherwise we update the child. It's this way. Okay, we update 01, 01. That seems right. Did I mess up on the wire? No, so then what is wrong? Is it 0 or 1? Did I mess up the... Oh, it's giving something. That's good, maybe? Not really. Poop. I have to come back to this. I'll show this match substream. This is a rough contest, obviously. We have actually 2 minutes left. Clearly I needed to do Q3. That was a disaster. Q3. I mean, I feel this is roughly right. I'm just a little bit off. Actually, I don't remember this problem anymore. I should have skipped it. Do we need 13 people solve this one? I mean, I think this is roughly right, but I don't know why this is wrong, honestly. Oh, I have to debug it, but Q4 was pretty straightforward. I don't know. Knowing the answer, it is straightforward, but we have 22 seconds left, and I think this is my worst ranking ever, but or like for a long time. I don't know why I don't know this one. I mean, I do know this one. I am doing it. It's just that, why is this wrong? I'm about to upsolve it. This is a disaster. Chef stayed in bed. But no, it's... Q4 wasn't that interesting. This one isn't that interesting either, to be honest. There is a known thing for it, but I don't know why I'm doing it wrong. Clearly. Do I need to propagate? I think I missed the propagation. No. But I don't know why this isn't doing it. Count. No, don't go. I always confuse whether I should be start at 1 or start at 0, but I think it's this at 1, so yeah, I think 1 is actually right. But so 1, the total is 1. So then what's wrong? What is wrong? Where did my new point segment go? Oh, right, Y and query. Oh, no, but this is because okay, let's do it before we update it. Okay, so why is it returning this ridiculous thing? Or where is it printing this entire? So 0, 1, 1. So I guess I had mostly right. Then why is this returning this ridiculous thing? I know that I have a py thing, but is it because I'm dumb? It is because I'm dumb, because I forgot to update this thing. I thought I had code there, but I probably just deleted it. That's why. Okay, so I was just being dumb. Okay, because I think I just rushed it at the end a little bit. Okay, so then now, I still have one print statement I don't want. Oh, that's in there. I had it, I suppose. Okay, that's what I want. Can't believe I was just being dumb. Okay, so 2 and 4, so this is right. So then now, we have to find a y where this is the case, right? So, okay. Okay, so if current sum, okay, oh, okay, so let's, because we don't want to binary search. Not like that anyway. So okay, so we calculate that, right? So whatever, let's just return current sum. So then now we have total is equal to this, right? And then I wonder if there's an easier way to do Q3, but I guess we'll look it up afterwards. But okay, and then now we do it again, but then now do half, right? I was trying to use the same one, but I think I'm just a little bit lazy. So because basically, okay, so then now if current sum is greater than total or times 2, then now we want to binary search on here, right? Because we know what, okay. Is equal to this. So if this is greater than 2, then now what we want is just solve for it, or maybe even just binary search really. Whatever, 10, right? So then now area is equal to, oh actually this should be between previous y and the current y, so then it is just mid is equal to, I guess I probably was very close, but I just had that typo that I couldn't figure out, and I mean I just ran out of time really. I don't know. I mean, I think this isn't. And that's basically it in theory. Unless total sum is 0 or something. I don't know. I mean, I don't know if this is right, but it should be pretty close. I don't know, whatever YOLO. Okay. Oh, is it because I'm using int? Or is it because I don't know? I don't know. Area is equal to, I don't know. I mean, this seems like it should be right, but okay. What is this? 21. So I did that, I'm confusing. So why did it? Oh no, you idiot. I mean, it's fine, it's after the contest, but okay. That is just silly. That's the actual height. I might have gotten it wrong anyway. Okay, so if it's too big, then we want to try smaller. No, this should be more right anyway. I don't know if it's right. Oh no, it's previous y, Larry. So many silly mistakes. Ooh. Why would this go out of bounds? Is this +1? Is that why? That's actually a little bit sad. But I mean, I think like the idea with mostly right. Apparently my segment tree is a little bit off. But I did forget that I have like 10 minutes apparently. That's why we're so slow due to silliness. But otherwise, I think we probably would still been okay. Maybe not. But why is this out of bounds? Out of bounds on here. I don't know. It's out of bounds on. Oh no, this was out of bounds on here. But this is a different out of bounds. Do I ever use this? Oh yeah, that's right. This is. No, this is very well, but it's not a big deal. Oh no, is it wrong? Maybe I'm confusing things again. Why don't we use the lookup though? Oh. That part doesn't make sense, but L and R. Why? Right. Right. No, that seems right. Reasonably. Okay. So then, what is out of bounds about it? 0. What am I putting? Silly debugging things. Oh, I'm looking at here. 0401. Zero 1 is weird. Why are we doing 0 1? Never do 0 1, do we? Oh, this is on the. It's erroring out in the earlier examples and not the later ones. That's why it's confusing. Okay, so it's erroring out in here. Why? What did I change again? No, I just changed this thing. How is it that this? Oh no, because I changed this as well. Huh? Like why would this change anything for that problem though? That is actually confusing. Why would that change anything? With respect to our bounds. Okay, well. Why? How does this? Maybe I just had to fix the other thing. But why? I mean, the wrong answers don't matter anymore anyway, so let's look. Okay, so here it tries to do 17, 18, increment by 1. Okay, well, where is it out of bounds on? On what query? I'm so confused. Oh, is this thing where it's just too big? Oh, I see. That's easy fix, I suppose. Okay. I'm just being dumb. Okay, how do I do it? If that's fixable, but how? Why do I? Where's my print statement? I'm just trying to get rid of my print statements before YOLO submitting again. Honestly. Okay, let's. Oh, still print statement somewhere. Maybe. Yeah, I'm a little bit sad. I mean, because I had the idea for this one. I just kind of took a long time, right? Due to not, due to a typo. I mean, this part I would have taken the wrong answer anyway. So, but everything else, I think mostly was right. I just forgot this line, and then the output was very confusing because I forgot this line. If I had gotten this line, I would have tried to solve for it. I don't know if I've gotten Q4 though, so I don't know. Like, when I've gotten Q4, like I was very tight, right, with like 2 minutes left. But this, I don't know. This was very dumb too, so I don't know. Like, I was pretty dumb on both problems. Like I guess I was trying to do DP in my mind, but with greedy makes sense here. I am curious how to. Well, okay, this is how ChatGPT would have done it, I suppose. Segment tree. I don't know if this. Wow. I guess I don't look at the top leaderboards that much, but clearly it is. Did everyone just do a segment tree? That is actually ridiculous. No, someone did it. No, this is a segment tree. Did everyone just do a segment tree? I mean, I knew how to do a segment tree, but. Everyone is doing segment tree-ish. This is what I wanted to do. Actually, I wanted to do it this way, but to calculate the unions on all the segments and all these things. But no, maybe I'm wrong. Actually, maybe this is still a segment tree. Yeah, I don't know. I guess it is just segment tree. I knew how to do it, but I guess I confused it with something else in the beginning, and then yeah, this part it is fine, but I don't know. A very weird contest, but yeah. It's not really interesting. If the only solution is segment tree, it's not very interesting. I mean, well, there is a sweep line for sure. I knew I wanted to do it, but yeah. And actually, I think this could be solved. Actually, I was just, is that true? Yeah, I mean, you have to think. So this is just solvable. So let me upsolve this a little bit by saying that, okay, so we're trying to solve current sum plus sum area times 2 is equal to total. So that's what we're trying to get, right? Or more precisely, times or plus current width times some let's go with this, right? So we're going to solve for this, and then now we can just do current sum divided by current width, right? And then that's equal to, and divided by 2. So then you have mid minus py is equal to this thing, and then you just yes, plus py, right? So I think you could do that. I mean, this was I don't know. I don't know that matters that much, but ooh, already rounding error maybe, or huh? That's actually wild. Did I do the math wrong? So at this, where we're trying, what are we trying to solve for? Right, we're trying to solve for current sum plus current width times some mid minus py. Oh, I put the 2 in the wrong place. There should be this entire thing times 2 is equal to total. So then now this over 2, and then is this minus current sum. Okay, these effects, right? We don't even need to get rid of it because I don't know. I still don't like this one because it's just like very I mean, that's why a lot of people got it, is that it's just very specific, right? Like there's nothing interesting about it. But I didn't remember this one. Well, I wanted to do it the other way. That's why with the with keeping like a sorted list set, but I guess that's much harder. I think I'm wrong on that one actually, because I think you can create a lot of segments. I'm thinking of a version where I mixed it up. I think I'm thinking of a version where you can only create one new piece, but in this problem you can create a lot of pieces. So now I think segment tree is the way to go. But it's a very stupid problem because it's just very trivial, very trivia. So yeah. But yeah, yeah, I don't know. I don't have much to say with this one. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and this contest, and this explanation, everything in between. Yeah, stay good, stay healthy to your mental health. I'll see you all later and take care. Bye bye.